In Unreal 5, we can create things that are called smart objects. So what is a smart object? Essentially, a smart object is an object that you can add to a level, and an AI agent can interact with that smart object. And it is the smart object itself that contains the behavior for that interaction instead of the AI agent. And it has this concept of a reservation system. So as you can see here in this smart object, the behavior is that it will move each one of these AI agents to an empty pod, and through a reservation system it will ensure that they never go to the same pod. So they're always moving to a different pod. Then the behavior is they will rotate to face outwards, and they will keep switching their pods, but because of the reservation system they will never go to a pod that is already occupied. To use smart objects in Unreal, we must first go to our plugins and activate the Smart Objects plugin, and then restart our editor. And the way that smart objects work is that we add a smart object component to an actor. So I've created this actor, which is just an actor with these teleporter static meshes. And to add once you've activated the plugin, you should be able to add a smart object under Gameplay Smart Object, which gives you the Smart Object component. So that is just a Smart Object component which has been added, and in itself it does nothing specific. To use it, you have to create a Smart Object definition. So when you click on the Object component, under Smart Objects there is a Smart Object definition. So if we go back and we right click, and now that we've activated the plugin, under Artificial Intelligence we'll be able to create a Smart Object definition. So if we say that Smart Object definition for our teleporter, and if we open that, so we get this viewport and we get details on this side. And the way that smart objects work is that you are adding smart objects as slots, and those slots will have a location and a position to which you can move your AI agents and rotate them and so on. Under the main category, you can add parameters, you can add default behaviors and tags, which will then apply to any of your slots. So if I create just one slot to see what it looks like, so this is the appearance of it, and you can give a slot a name, you can change its visual color, its shape from circles to rectangles, you can change the size at which it appears, its offset, rotation, and then you can use tags through which you can filter which slots are returned by the smart object. And by that way you can control whether an AI agent moves to a particular tag or a different tag. They also come with these behavior definitions, so you can add those, and they have something known as a definition data. So if I click on that, and then you have access to use a collision, an entrance, or a slot link. So you could add an entrance. So a slot can have a slot location, but it could have an entrance which is at a different location. So again, here we click on that, we could move the entrance to be here. We could rotate that entrance so it's facing the other way. And we can mark that definition data as either an entry or an exit. So this one could be your entry, and then you could create another definition data. This could be your exit, and we could move that back. So first we need to, in the new one, obviously set it as an entrance, and we can open that up, and that one is located here, and we could set that as being an exit. So in this smart object, the behavior might be that the AI agent comes to the entrance and then he walks to the exit position. And that would be part of the definition of this smart object. Now, if we go back to our teleporter where we created the smart object and we add this smart object definition, SO teleporter, you see that it shows up here. So if I just move that to make it more obvious. The problem is though, we may want to place the locations precisely in the right place for this teleporter, and you cannot change them in the actual actor. And it would be quite difficult to just randomly, through trial and error, accomplish that. So it can be easier in your smart object definition. If you go to the preview, we can find our tutorial teleporter. And now we get the teleporter actor object as a preview, which means that we can then position these exactly where we want them to be. So if we get rid of the old slot and then create a new first slot, we could name this and call this our first slot. We'll leave the color the same and the shape. And then we just want to offset its position so it is located here. So we can click on that and now we can move it in the viewport. And then we can just find a perfect location to place it. From this arrow we can see that it's actually facing in this direction, and maybe in our behavior we want the AI agent to move here and then to face outwards. So we want to take advantage of the built-in data that comes with the slot. So we can rotate that. We could rotate that, say, 90 degrees, and now it's facing outwards. We also, as we said, this data definition gives you access to entrances and exits. And we might want to just call that our entrance. So we'll create a definition data. We'll use entrance in this example. We won't change its rotation and offset because we want it to be precisely where the slot is located. And the definition data, we'll just mark this as an entry so we can unclick exit. We can leave the trace ground location because the AI will use that to find the actual position on the ground. We can alter things like its selection priority, and that can be something that we use to find the correct slot, but we'll leave that at normal. And that would be our first slot. Now some of these information you're setting here, you can set as defaults. So if you were going to use some of these tags that apply to all slots, or if the slots had preconditions, in other words, you could only enter them if you met certain conditions, you could add them just as defaults instead of having to add them individually. You also get these schemas, but there's not much you can change here in Blueprint, so we'll leave that at the moment. But there's information on what happens if you have multiple tags. Are they overridden or are they combined? Again, we'll look at that a bit later on. So to add another slot, we'll just click on the plus here. This would be our second slot. We could call that second. And we just want to move that onto this one here. So we can click there, just move that across. We then also add a definition data like we did we changed the rotation so it was facing outwards. And then we would add a definition data and mark that as an entrance. And just mark that as entry instead of exit. And we'd essentially just repeat that so we have a slot in each one of these pods which is precisely located. So by just clicking on the slot and duplicate, I've created 6 different slots which are located at the teleporter pod position in our actor. So those are our 6 slots 6 slots, and this is how they look like in the actual actor blueprint. So now we've got created a smart object component, we created a definition, but how do we use the state tree that comes with this? So if you go back to our smart object definition, and if you go to the default behavior definitions, if you click on that at index 0, what you're looking for is this gameplay interaction smart object behavior definition. Now this is not something that's present by default, so you have to go back to your plugins and enable the, it's called I think interaction gameplay. So gameplay interactions, it's an experimental plugin, but you need to enable this in order to get access to the state tree, and then just restart your editor. Go back to your object definition, and now when you click on that gameplay interaction behavior definition and you open it down, you now have a state tree that you can attach to this smart object, and the state tree will use its AI to control the behavior interactions of the AI agents. And each one of these slots will have its own, will run its individual state tree. So if we go back to our main level there, we'll just create our first state tree. And again, to use the state trees, just make sure your plugins are enabled. So state tree, I think you want, so make sure that the state tree and the gameplay state tree plugins are enabled. I think in 5.5 they're enabled by default, so that's fine. And then we can create our first state tree. So in artificial intelligence we should be able to say state tree, and in the actual schema what we are looking for is this gameplay interaction state tree schema. So that's the plugin we've just enabled. So we can call that state tree. So we'll just say st state tree, say teleporter. So now we've created the state tree. We can go back to our definition and we can add that as our state tree teleporter. So whenever we tell the smart object to use the slot, it will use the state tree as its AI. So we save that. So in our main level I've added our tutorial teleporter. When you click on it you can see the locations of the smart objects and their slots and which direction they're facing. And what we want in our behavior is we want an AI agent to move, to enter this box here, and then the state tree can make it move to an empty slot and rotate it to face outwards, and then keep moving it to different empty slots, and ensuring that the different AIs never try to go to the same slot which is already occupied by another AI. And all of that behavior should be built into the actual smart object state tree. So how do we find a slot and activate its state tree to control the behavior that will be applied to the AI agent? So we go back to our tutorial teleporter with a smart object. One thing we've created this box collision. So to begin with, when an AI agent roams into this box, it will trigger the overlap, and that overlap will then try to find a slot and trigger the state tree to control its behavior and move it to an empty slot. So in the box, the best thing might be if you go to add event on component begin overlap. This should then try to find and use a slot. So we'll just create a custom event which is find and use smart object slot. We'll want to send an actor reference, which is the AI character. So we'll create a parameter, we'll just call that actor, set that as an actor, and then on the component overlap, what we're interested in is in our particular character. So this is actually an AI character, And to begin with, all it will do is it will try to find our teleporter and move to its location. Otherwise, there's nothing too complicated in a basic character. So we'll try to search for the class of that character. So we'll say other actor, and we'll say cast to BPAI character. If that is true, we'll then call our find and use, and we'll send the character as our actor. So that will trigger the initial entry behavior. That will then call this, and from here we need to find a smart object slot. So one of these slots here, which is not occupied. And as I said, in smart objects you have this concept of being able to claim a slot. So an AI agent, when he enters, will claim a slot, and then another AI agent who enters will not be able to claim a slot that's already being claimed. And all of that is built into the actual smart object itself. So you don't have to do any of that logic on your AI character or AI controller. So if we take our smart object, so there's a number of ways that you can find a slot that you can move to. As we're doing this in the actual object itself, we can just use some built-in functions. But generally the way that they work is they use a spatial lookup. So you give it a origin location and a box to check in, and then it will look for smart objects in that location. But from the smart object component itself, there is a find smart objects in component. So this will find all the smart objects in this component, which is on our tutorial teleporter. It requires a user actor, so this will be the AI character that is going to be interacting or using this smart object slot. So that's our actor here that we can put in. And then you can create a filter, so you can only identify or return slots that meet certain criteria, because you might not want them to be able to enter any slot. And that gives you, when you open the drop down, so you can specifically tell it to, if you untick this, it will only find slots that have not been claimed already, rather than all of the slots. If you've disabled slots, you can tell it whether to find those slots or not. You can also create these activity requirements. So as it says, only return slots whose activity tags are matching this query. Now where are those tags set? Well, they're set in your teleporter definition. So if I open one of the slots, here you have activity slots. So you could define gameplay tag slots, and I've done videos on how gameplay tags can be created. You might say only smart object tags will come through this filter. That would be the activity tags which was on that previous node. You can also have runtime tags, so these are tags that can be added and removed. You can have these selection preconditions, so let's just look at a simple one. So click on it, it's drop down menu, so you can see whether they meet certain criteria or not. Do they match certain tags or not, for instance? But we don't want to do that, and we'll leave these tags off in this today's example. So if we go back, we can leave all of this as default, the main thing being do not include claimed slots. If we find any slots here, so we can branch, we know that we're not getting claimed slots, so all of these slots must be empty slots. And we just want to get one of these slots, so if we just get maybe the first slot, and this is an array of smart object request result structures. So this is a smart object request result structure. We can break that as it's a struct, and now we get access to the smart objects handle and to the slot handle. And these, when you look at this in the viewport, I mean, you notice that there are registered handles, so they will have IDs, and that's essentially what these slot handles are. I think they're just, I mean, you can't break these anymore, can you? No. And because they just have registered ID handles, which are numbers, you can obviously just copy them and save them somewhere. But in our case, if we find a slot that has not been claimed, the AI agent wants to then interact with that slot. So we can, first of all, we want to claim the slot. So mark the slot as claimed. We want to send the user actor that is claiming that slot. So that's this actor here. And you can set up claim priorities, so it will only claim. So claim priority is a slot claimed at lower priority can be claimed by a higher priority unless already in use. So again, you can use this for your built-in logic, but we'll leave that as normal. Once you claim it, you get a claim handle. And this is the handle binding the smart object. So it gives you a slot and a user ID. And that's all it is. It's a structure with a slot and a user ID. But from here, we can then use that slot. So using that plugin, the interaction plugin, we get access to two functions. We can either say move to and use a smart object with the gameplay interaction. So that will use the AI to move to that slot. Or we can just use a use smart object with gameplay interaction. The reason we're going to use this one is because we want to control the moving with a state tree. So we click on that, and then it just wants to have the controller, which is the AI controller of the object of the actor, which is going to be using or interacting. So we can just say from the actor, say get AI controller, and attach that. And then we can decide whether we want to lock the logic or not. So we might have to play around with that if things aren't working. And this is an async node, so once it's done the using, it will come through on finished, or it will tell us whether the state tree has succeeded, has failed, or if we're doing a movement on the move to failed, had come through. So I think these are whether the state tree is succeeding or failing. This is actually just whether the use has finished. But at this point, once we say use smart object, this will activate the state tree that we just created, which will be individual to each slot. So if we go back to here and we open our state tree that we created here and attached as our definition here, we end up with a basic state tree. This one has a gameplay interaction schema, so it gives us, it sends information on the context category, and I've done a video on state trees and how you can get, set and bind based on categories in your blueprint variables, so I'll try to link to that. What we get here are some useful information. So the state tree will tell us the context actor class. This is the AI character or actor that is interacting with this slot. It will also send us a reference to the smart object actor class. This is the actor on which the smart object component is attached, which in our case would be the teleporter. So this would be our AI character and the smart object would be our teleporter. So we could actually just set them specifically or leave them as actors. Just leave them as actors for the moment. The other information the state tree will give us is it will give us this object's claimed handle, which is this claim handle for the one that we've just claimed and sent through. It will give us the slot entrance handle. So we added an entrance in our definition data, we added an entrance data. So this is basically what should come through here, though it's not necessarily as useful as we may think. And then this abort context, which I haven't used much of. And the rest of everything else we can set individually. So the first thing we want to do is create our first task. So we'll create a task. So if we click on this and we go across, we can now start adding tasks. Now, once you've activated that plugin, and you get this category gameplay interactions, and you have access to a lot of different built-in tasks. Sync slots, you can set them enabled, you can send events, modify tags, get a slot entrance tag, get the slot actor, or you can find a slot entrance location, which is what we want to do. So we'll click on that. This now gives us this task which has been added, and you can select a method. Do we want to find the first entry location, or do we want to find the one that is nearest to our search location? We leave that at first. The rest we can probably just leave ticked on. And the location type, remember you could either have an entry or an exit like we did in our definition data. We'll leave that as entry. The user actor again will be automatically bound to this actor, which is our AI character. And the reference slot handle, we can bind that to our smart, so there's two options, smart object claimed handle or slot entrance handle. Well, we don't have a slot entrance handle yet, I don't think, so we can do a smart object claimed handle, slot handle. The result of this will come as an output to the entry transform. So when it finds the first smart object slot closest or in a particular distance to our AI character, it will write the answer back to the output. We can then use that to move to. So we can add another task and use the built-in move to. The destination we can now try to bind to this entry transform. So go destination, first slot entry, entry transform, and there will be a translation there. So we get the entry transform translation. We don't need to set the target actor. We probably want it to go as close to the location as possible, so we'll set that as 1. And we don't want it to include these agent radiuses. Now the issue is here, for the move to, you need an AI controller reference. But we don't have that, so that's one thing that seems to be lacking. So not only can we not gain access to it, even if we were to change the context, so it will say no AI controller. Even if we were to change the context here to our VP tutorial, so AI character, we still can't get access to the AI controller from there. So we'll need somehow to do this. The best way is probably we'll need to create our own global task for that. So we'll just create a new task, state tree blueprint base. We'll call that state tree get AI controller. Put that back there for the moment. So we go to our state tree task on the enter state. So we'll need to get the AI character to get its AI controller. So we'll need a variable, which will be our actor. We can just put that as actor, object reference. We can set this as context, so it should automatically get bound to the actor. Then we can get the actor, we can say get AI controller. And we can send that back as a variable, promote to variable, AI controller reference. And as we're sending this out, we'll put that as output. So I said in the previous videos I've shown what all of these categories mean. As this is a global task, we don't necessarily need to finish it, so I'll just leave that there. Go back to our state tree on the global tasks. So this should start running right at the start of the tree. We can find our STT get AI controller. So that will bind automatically to the actor, and it will send this output as an AI controller reference. I'll just make this so you can see what's happening. So here on the AI controller context, we can now bind to our state tree task AI controller reference. So that should get rid of the issue we're having there. So if this was working, technically this state tree should get activated. It should find the location of the first slot and it should move there. We go back to our tutorial here. So again, once it comes into the box, this gets activated, finds the slot, does the use, and then I'll just put here, just put a little hello that says tree activated. But let's see what happens. So if I play, so he runs into the box, but nothing. We get the tree message. So we get the tree activated message there, but obviously he doesn't move to the actual slot. And the reason for that is that the way smart objects work is that they use a spatial lookup. So they're taking the actor that we're sending in and doing a spatial check in a particular sized box to find a slot, which means that when you go back to your state tree, there is this validation filter which we haven't put in, and this is actually important because it defines the box in which the find entry location will operate. So we have to create a validation here. So if I just go here, create new blueprint, just put that in our smart objects, and we will say slot find validation filter. Save that. We open it. All it is if you go to the class defaults, is it has default options. So navigation filter has a search extents. So we want those extents to be pretty large because the size of our sort of actor here goes from -200 to maybe 1800. So we want it to be at least 2000 in size. So we'll say search extents, maybe just put 2000, 2000, and just maybe 100. The trace parameters, so we can leave by visibility, and the transition parameters, so we're not really using those, but we can leave those and use the same entry parameters for the exit. And if you were using capsules, you would put that data here. But the key is we need to attach that to this validation filter because it defines the box in which the search will take place for a slot or a smart object to location to move to. Now if we go back and try to run it this time, will it move to a slot? So now he moves to the first slot, which is what we wanted him to do. And he's pretty much in the right location. The next thing we want him to do is to then rotate and face outwards, because in our we set the arrow to face outwards, so there is a rotation that we can gain access to as well. Go back to our state tree. We'll create another state. So we'll say rotate to face outwards. We'll need to create a task to do this because there is no built-in task for that. So we can't get the transform and rotate with this. So we'll new task, state tree blueprint base, STT, we'll just say rotate outwards. That will open our task. We'll do the enter state here again. We'll need access to the character because that's who we're rotating. So we'll say our actor. Put that as an actor. Object reference. Put that as a context. So it's a context actor, automatically bound. So how do we get access to the transform of the slot? Now in Unreal, there is a smart system, there is a smart object subsystem. So if you right click and search for get smart object subsystem, this also has a lot of functions. So for instance, if we want to say, if you type in get, if you just type in slot, let's say slot for instance, Under Smart Object, you get access to a number of different functions. So you can set the enabled or disabled, remove tags, get slot transforms, get the slot state, its location, all of the slots, and add tags. What we want though is to get a slot transform. And it says associated with the claim handle, because we know that we can get access to this claim handle from the state tree. So if we then just promote that to a variable, say that's our claim handle, we want it to be set. We know it's on a context, so we can say context. So that should hopefully get set there. And this gives us the slot transform of that smart object. So we're interested in the rotation from the transform, so we can split it, we get the rotation, and if we want to just rotate it gently over a length of time, we can just get the event tick, we can get this rotation, we can get our actor, we can get its rotation first, get actor rotation. We can then say set rotation. And we can interp these values together. So we can say rinterp, rinterp2. The current would be the actor starting rotation. The target would be these slots rotation. This will be our delta time. Maybe just put that as 3, and then we can just set that rotation here. We can then maybe just check to see if the rotations are equal. So get actor rotation is there a nearly equal? No, just equal. If it's equal to the slots rotation, we can just branch, and if it's true we can maybe finish the task as succeeded. Let's just put a little 0.1 there. So in our state tree we can go to rotate to face outwards. We can then try to add that task that we've created, which was STT rotate outwards. These should be automatically bound as context. And again, in the claim handle, as I was saying, basically there is an ID. And again, the user handle has an ID, and that's how they are uniquely identified. So when we do the move, when that is finished, so on state succeeded, or just say state completed, we should go to our rotate to face outwards. Now if we run our game again, what happens? So he goes there, he then rotates to face outwards. Do that again. He runs to the slot, finds the slot, rotates to face outwards. So that's our behavior. So in our teleporter blueprint, once we've claimed the slot and used it, are we getting these finished or tree succeeded messages coming through? So let's just play. So he goes there, we get tree activated. He completes the rotation, but no, we don't get the finished or succeeded. So at some point we want to finish this tree. So if we go to the rotate face outwards, on a transition we can say on state completed, there is a tree succeeded option. So if we click that, and then we play again, so in the top left we get tree activated, completes the rotation, then we get the tree succeeded and tree finished messages. So that tells us that the state tree has now completed its AI logic. The other thing is, as I said, the concept of these slots is that you claim them, then you use it. When you use a slot, it should start changing the slot state, so it should then become occupied. But in order to use a slot after that, you do have to free it. Now on your smart object, if you click on that, you notice that there is an event available here, on smart object event. Let's click on that. Let's see what happens, what information we get automatically. So we get the interactor, which is the AI character that is interacting with us. The event data, this is of type smart object event data. If we break that, we get the slot object handles. We also get this reason. So let's just maybe print that reason and see what this event automatically being sent is. So first of all, if you just do a switch, you can see what types of information come through, what option. So you can get unbound, objects disabled, released, occupied, claimed, and these are the main ones when tags are removed or just an event. So let's see what comes through automatically. So we can do this to string, enum to string, and we can put that, our reason there, and just make it stay maybe a bit longer, 5 seconds or 10. So automatically when we play, we get this. So we get the on component bound, we get on claimed, which we did, on occupied and on released. In that order, on claimed, on occupied, on released, then the tree is succeeded and it finishes. So what this tells us is that this node, so we claim it, we get the event on claimed. Then when we do the use smart object with gameplay interaction, it automatically occupies the slot, and then it, let's see where's it gone? So on claimed, then it occupies it, and then it releases it, and then at the end it automatically releases it. So this is the order in which it happens, those events. So component bound, then we get the on claimed, the on occupied, the on released, which frees it, and then the tree is succeeded, it finishes, and the on component unbound gets called. Now we might not want it to go from on occupied to on released straight away, because if we want our AI character to remain in that location, we don't want another character to try and move into that place. So we might want to delay one going on to the next, but at least we know that we don't need to call the on occupied or on released ourselves. There is a way of doing that, so you can just go from the claim handle and say mark smart object as occupied, but this seems to do that automatically, so we don't need to do it ourselves. We go back to our state tree. So we've ended the tree here, so we've gone to the location, moved there, rotated to face outwards. What we might then want to do is maybe try to find another slot to move to, which isn't occupied. And we don't want another AI character using this tree to move to our slot until we have freed it. So we should create a new task here. So if we say root add slot, this will be find new teleporter slot. We can then maybe add a task. Now we could just send an event. So there is an option here that says, and where's it gone? Send slot event. You could give it a tag, you can give it a payload, and then trigger when, set the state and when it's triggered. That would come through here to our teleporter on the object event, and it would come through on the on event. So that's one way that we could do it. However, that is probably not the best way of controlling this. We'd rather do that in the task itself, but that's something to be aware of. Now this payload doesn't come through in the blueprints for some reason, because if you go back here, even if you set a payload, this data comes through as a smart object event data with no payload, and there's no way to get the payload from here. So maybe that's a C++ option until it's changed in the next versions. So we'll create a new task here. So new task, state tree blueprint task base. This will be state tree task, STT, find new slot. Save it, open it, and we come here. So we can do the enter state. And now we need to think, how are we going to find a new slot? Well, we know that in our teleporter itself, we do have this find and use smart object slot function. So we should try to maybe take advantage of this in our state tree. So one thing we can do is we could create if you go back to our state tree, and originally I said to leave the smart object actor as an actor, but we could maybe just set this as our tutorial teleporter to make life easier. So trying to change this smart object class caused the entire editor to crash, and this is an odd issue with state trees, that little changes sometimes just cause it to crash. This was particularly bad as I had to delete the state tree and make it again in order for it to work. But we're back to where we were. We've got our task find new teleporter slot to move to, and I've changed these from the start, the context actor to our AI character and the smart object to our tutorial teleporter. So in the actual task, if we now try to get our teleporter, and if we call that a BP tutorial teleporter object reference, put that as a context, and if we get to our actor itself, and that's BPAI character object reference, put that as context. So in our state tree they should be bound. Smart object actor is the teleporter, the other one is our actor itself. On the rotate to face outwards, we can then change it from state completed, instead of tree succeeded we can go to find new slot. Then on the enter state here, what we want to do is we want to, with the teleporter, we want to tell it to use that function find and use smart object slot, and we can send the actor as our variable. Once we use the find function in the teleporter, we can do a little delay, maybe 1 second, and then we can just finish the task. Because when we finish the task, we can then tell it to complete the tree. So here we can say transition on state completed, tree succeeded, and what that will do is it will then free this slot that we are in after we've moved away from it. We might want to maybe just put a little delay here to begin with as well, so it stays there for a small while. And then if we go back to our map and if we play, so he moves to the first slot there he can find, rotates, waits a little bit, then looks for another slot, and then he will. So again, the fact that he's moving back and forth tells us that it's being released. So we know it works with 1. I've now created 4 duplicates of our AI character. The only thing, and now let's see whether 4 of them can all do it together. So to begin with, they all move correctly, and they start moving across there. So 2 of them have found a slot. Now 1 of them has got stuck there, as you can see with this guy in the middle. 2 of them are trying to go to the same slot. The problem there is probably that there's 4 of them and there's only 6 of these. And if we go back to our teleporter here, the one thing we do in this find and use is we check to see if the claim handle is valid, or did it find a successful smart object. So it's possible it doesn't, so we might want to put a little delay here. And if it doesn't, we can tell it to wait a delay and then find a new smart object again, so to try again. Now if we do it, let's see what happens. So they all find their original slot, claim, occupy it, then they start freeing it, then the other ones start moving across. They all get into their correct slots. And now they keep doing that, and they should never be trying to occupy the same slot. Okay. So using our smart object component with a smart object definition with these smart objects as slots, our AI characters can now interact with a smart object, and the smart object is controlling their behavior using its state tree, which is just a few tasks: find and move to slot, rotate to face outwards, then find a new slot to move to, and succeed the tree. And that allows that behavior we saw to be executed. The one thing here though is that in order to find these smart objects, we've been using this smart object component find smart objects in component. Say for instance the AI character wanted to find a smart object in its vicinity. Well, we looked at the smart object subsystem, and from here there is a find smart objects or find smart object. So this one is often useful. So this will look for smart objects in the vicinity of the AI character, and you just create a smart object request. It needs a box, so you have to make a box, and that's the area in which it will search. So make a box, give it if you use this version, it needs a minimum and a maximum. So you would say get actor location, and maybe minus, so like minus 1,000 to get the minimum, and you would just add 1,000 to create your box. You can give it a filter like you could previously. So again, this is how you would search for the smart objects that meet your criteria. And then from here you would get, maybe just got the first one again. That is a smart object request structure like we had before. You can break it, you can claim it, and the claim handle, you can use it or you can move to it. So that would just need a controller. We just need an AI controller, claim handle, and all of the rest is very similar to what we did before. So that's a quick overview on how you can use smart objects with state trees in Unreal 5.5 using the gameplay interaction plugin. And this can be particularly useful if you wanted your character to, for instance, find a cover location, or to go and interact and sit down on a bench. And there's lots of extra things that you can do. You can also add contextual animations and so forth. But we'll leave it at this today.